Hello everyone, welcome back to my YouTube channel. In previous video I had shown you the comparison for the dynamic mesh and sliding mesh for rotating body. In today's video I am going to make a comparison for this sliding region. It means I will increase the area of this sliding region and we will see what is the impact of this sliding region on the simulation results. By the way, in the description I have included Amazon links for some good CFD books and useful tools. Using these links also support the channel. You can also support the channel via PayPal. This one is the animation from the previous simulation. So I'm just going to show you the temperature profile. That's how it looks like. And here is a pressure profile. In this video, I will not show you the workflow for the sliding mesh as I have already shown you in my previous video. You can check that one. But here I will show you the changes which I will made in the geometry to create different region, and then we will see what can we do. Let's move to the workbench. Here is my project schematic in the workbench, and this one is the sliding mesh, and here is my geometry. Let me duplicate this one. I don't need to do all the setup from zero because I have done this setup. I just make changes into the geometry and I can run this simulation from outside. So I'm going into the geometry. I am in the geometry. Let me show you something. Let me go to the measure and measuring from center till this edge. And you can see it is almost 30 millimeter, and also I can measure from here till here. It is 33 millimeter. It means this sliding region is 10% bigger than this blade. Now to increase the size of this inner fluid, let me hide this outer region and I will say pull and move this one by 3 millimeter. Similarly, let me bring this one and hide this one and select this one, again pull and move this one outside by 3 millimeter. I'm just pressing 3 on my keyboard and it is by 3 millimeter. Now you can see this circle is 72 millimeter or 36 is the radius from here till here. It is now 20% bigger than these blades. I can close this one and all the setting will remain as it is. Just one thing I have to do in solution initialization method, it should be solver control. If I will say program control, so it will start from the end result of my previous simulation. If I will say solver control, so it will use the initialization setting which I have used in my solver. Now to run simulation, I don't need to do anything inside this setup because mesh and everything has been set up through name selection. I can just say update this one. When I will say update this one, it will update mesh setup and it will run simulation. I will get results from outside. Oh, let me say update. Just give me a few minutes and you can see mesh is updating, and when it will come to the solution I will show you over here the solution progress. It might take a minute or two. You can see mesh has been updated, setup has been updated. Now it is running the simulation. Right click on this one and say solution monitoring, and when you will monitor over here, and here are my simulation setup, everything is in here and you can see these are my residual here outlet temperature, and you can see I did set up my outlet temperature in the sliding mesh and it is plotting my outlet temperature. That's the benefit of setting your simulation setup with name selection. You can check in my sliding mesh video. I did mesh setup with name selection. I mean the sizing and the inflation layer, those are with name selection, and when I made changes to the geometry, the setup will remain as it is. Anyway, the simulation is running. I will not wait for the result. I have already run all 4 simulations. I will just show you the end result. For this sliding mesh, I have run 4 different simulation in which I have increased this region by 10%, 20%, 30%, and 40%. Here is the simulation result for the 40% extra inner fluid region. Let me show you the animation. Here I have a pressure animation, and also here is temperature animation. So pressure field and temperature field as well as velocity field are all same for all 4 cases. You cannot spot a difference like that. They are looking similar from the scale point of view as well as from the distribution point of view. I have also recorded the outlet temperature for all 4 cases. I have run all 4 simulation for the exact same simulation setup. I mean, the velocity is same, the temperature is same, even the number, not the number of element, but the element size in the inner region is also same. I mean, in the sliding region and the stationary region. Of course, the sliding region was increasing. It means where I have this 40% sliding region, it has more element, but the sliding region in all 4 cases have same mesh refinement. So let me show you the outlet temperature for all 4 cases. Here is the outlet temperature for all 4 cases. Inner region 10%, 20%, 30%, and 40%. And you can see the temperature profile are close, not exactly the same, but let's see this blue and yellow line for 10% and 20%. These are comparatively close and looking similar. It means 10 to 20% region does not have any impact on the simulation result, but when we go 30 to 40%, there is a slight change in the outlet temperature. But if you look at the temperature 301, 301.5, so zero point 0.5 degrees Celsius, and I don't see that the difference is that big. And but the distribution of the outlet temperature follow the same path. Yeah, there is a slight delay, but I don't think so it has much impact. But anyway, for this sliding mesh, I would prefer to stay up to 20% region because that's what Fluent Guide says. But anyhow, I do not have any experimental setup to check which one is more closer to reality. So based on the Fluent Guide and these results, I would say 10 to 20% region should be fine. That's it for today. I hope you found this tutorial helpful. Thanks for watching and see you in the next video.